Hello everyone, welcome back to another exciting video in chemistry lessons by Adrenaline the Bazooka Prophet. Now we're going to be continuing from our question answering on that thermodynamics, and in this particular video we're going to be answering questions. Now this is the part 2. Now the question says, when heat is absorbed during a chemical reaction, the reaction is said to be, when heat is absorbed during a chemical reaction, the reaction is said to be, is it thermodynamic, is it exothermic, isothermal, endothermic, or thermostatic? Now, before we answer such question, we should understand some basic principles behind it. Now, we should understand that we have basically two types of heat of reaction. We have basically two types of heat of reaction. We have the first one, what we call exothermic, and what we call endothermic. So basically, the two types of heat of reactions are exothermic and endothermic. Now, the opposite of exothermic is for what now? Endothermic. Now, what are their characteristics? Very simple. For exothermic, heat is what now? Heat is liberated or evolved. Take note, heat is liberated or evolved. Is that clear, Nana? So if heat is evolved for exothermic, what does it mean? It simply means that delta H, which means change in enthalpy, will be equal to what now? Negative. Take note, for exothermic reaction, delta H is what now? Negative. Now, if delta H is negative, it simply means that the summation of the enthalpy of the product is less than the summation of the enthalpy of the reactant. Take note, these are very crucial and very basic points. Do not forget. Now, while we continue under exothermic, we should also understand that the reaction vessel in exothermic is warm. Is that clear now? While we also continue again, we should also understand that in exothermic, right, there is always an increase in temperature. Take note, in exothermic, there is an increase in temperature, and a more stable substances are formed. A more stable substances are formed. And if that point is clear, we should also take note that all combination reactions are exothermic. A very good example of exothermic combination reaction are a reaction between calcium oxide and water, which is quicklime and water. Another example again is the reaction between an acid and a base, which is a neutralization reaction. Is that clear now? That is for what now? Exothermic reaction or processes. Is that clear? While we continue, we should understand that I have just told you that the opposite of exothermic is endo. It simply means that in the case of endothermic, heat is absorbed. If heat is absorbed, delta H is positive. Take note, delta H is what now? Positive. And if delta H is positive, what does it imply? It implies that the summation of the enthalpy of the product is greater than the summation of the enthalpy of reactant. Or also take note, it leads to a decrease in temperature. The reaction vessel in endothermic is cool. And all decomposition reaction, such as the decomposition of calcium carbonate to give me calcium oxide and CO2, is endo. Also, the decomposition of ammonium chloride yielding ammonia gas and hydrogen chloride gas is endothermic. And take note, a less stable substances are formed. Now, with all these points now, we could basically answer this first question. They say when it is absorbed, take note, when it is absorbed, we should understand that it is an endothermic reaction, because in endothermic it is what na absorbed, but in exo it is what na liberated or evolved. So the correct answer here is endothermic what reaction. I hope that is well understood. Okay, so we could basically erase this place so we can create more space to answer it. Now number 2 says the reaction, as you can see right here on the board, of carbon and iron 3 oxide to give me iron and CO2. Then I said delta H is equal to what now? Minus 46 kilojoule. Is what? Is it adiabatic, isobaric, endothermic, exothermic? Now take note. This answer will be what now? This answer will be exothermic. Why? Because delta H is negative. Whenever delta H is negative, it is exo. If they are put plus here, it should have been positive. So because delta H is negative, it is an exothermic reaction. It cannot be isobaric. Isobaric simply means constant pressure. Is that clear now? That's the meaning of isobaric. It cannot be adiabatic. In adiabatic, it is a type of reaction in which it is neither evolved or absorbed, meaning it is equal to 0, because there is no release of it, neither is there an absorption of it. That is in the case of adiabatic process. So the correct answer here is what now? Exothermic. Now, why I erase the board, please take note of it. I erase this board here. You should understand some basic points here. Now, the last of this question is in the reaction, Roman figure 1, this is what you have, minus 286. Roman figure 2, delta H is minus 406 kilojoule. The question now says the equations implies that. Now, when you see something like this, let me quickly give you a breakdown. You have minus 286 kilojoule, you have minus 406 kilojoule. It simply tells you that because delta H here is negative for both of them, it means that it is released. Exactly. So this minus sign here you are seeing here simply indicates that it is released. That is just the meaning. So if the options are telling you absorb, then that option is wrong. Now, if you get something here, you have 286 here, 406 here. Because the value of the Roman figure 2 is higher, the more heat is released, while lesser heat is released or evolved. Now, they say, hey, more heat is absorbed. Of course, that will be wrong because of that word absorb. It's wrong. More heat is absorbed in Roman figure 2, which is in the case of B. That is not also correct because heat here is evolved, not absorbed. Now, C said less heat is evolved in Roman figure 1. Look at it here. That is the correct answer. You don't need much talk anymore. Lesser heat is released in Roman figure 1, while more heat is released in Roman figure what now? 2. And that marks the answers here for the part 2. Watch out for part 1, for part 3. If there is any question that you want to ask, do well to lay it in the comment section below and I will respond. But before then, let us quickly do some certain things. And what should that be? The energy profile diagram of exothermic and endothermic. Is that right? Now, in the case of, this is it. This is for exothermic reaction. Now, for exothermic reaction, the reactant, right, is always higher compared to the product. You see now? So here is reactant, let's say A plus B. Here is the product. Now look at it. Look at it. From year to year, delta H here. This sign means change in enthalpy. But from here down to this place here is activation energy. Is that clear? This is potential energy. This is reaction what? Coordinate. Now take note. Here is called your activation complex. Take note. Delta H here will be equal to minus kilojoule per mole. This is for an exothermic process. Please do not forget it. Now take note that this is for an uncatalyzed. What's the meaning of uncatalyzed? Catalyst has not yet been added. When catalyst is then added, it will lower the activation energy, 1. It will speed up the rate of the reaction, 2. And it will create alternative routes for that reaction to occur. Please do not forget that point. This is for what now? This is for exothermic reaction. Now look at it. Look at it. What I just same for endo. Now, in the case of endo, where it is absorbed, in the case of endothermic, where it is absorbed, take note, the reactant is always lower while the product is higher. So it becomes like this. From year to year, delta H share, of course, is positive, kilojoule per mole. Right from here straight down to here, it's your activation what now? Energy. Do not forget it. This is C. This is A plus B. Remember, the composition reaction in the case of endothermic reaction. Now, this marks the end of this particular segment. We have to move into solve more and more past questions from WAEC, JAMB, and A-level exam. Thank you and God bless you.